Today you are going to see the class on mold design for the diploma tool and die making. Here today I am going to do the mold design class on the given component. Given component is as shown here. Component front use there and component top use there. The component material is POM, that is polyoxymethylene, and the shrinkage of the component is 2%. General tolerance of the component is plus or minus 0.1 mm. Draft angle is 1 degree permissible. Here I want to give a introduction to the component. Here the component is the outer diameter is dia 50, and the slot angle that is given is 45. Outer side of the slot diameter is 45. This one outer diameter is 45, and the inside diameter of the slot given is 38, and the outer side of the slot is 46, and this one slot diameter is 44. Slot inside diameter is 38. Slot outer side diameter is 46, and here you are seeing the straight portion inside the component, that is 30, diameter 30, and the angle that diameter is 32, and this straight length is 2 mm, and the angled straight length is 1 mm, and the total thickness of the component is 12 mm, and the slot that is our groove, you are seeing here groove on the component, that depth is 4 mm. You are seeing that depth is 4 mm, you are seeing, and the total thickness of the component is 12 mm. Again one time I am going to give the dimensions of the component. That is the total outer diameter is 50, and the groove outer diameter is 46. Groove another diameter is 36. Groove internal diameter is 44 and 38, and component internal diameter straight diameter is 30, and the component internal angle diameter is 32, and the component straight length here I am showing here, this one is 1 mm, and the angle length is 2 mm. You are seeing here, I already told you the material is polyoxymethylene, shrinkage 2%, general tolerance plus or minus 0.1 mm, draft 1 degree permissible. Here this component requires here this component requires the plastic injection mold, and this component is for 4 cavity plastic injection mold with the submarine gate and angular cooling and sleeve ejection and the sleeve ejection. You are watching here. I am just briefing about the principle of the plates and here the inserts. You are observing the placement of the component as shown in the figure, like that. This one, this plate is you are knowing the cavity housing plate, core housing plate, core back plate, and here the insert, cavity insert, and here the core insert, and here you are seeing the core insert. In this you are watching this one. This component area is machined in the core insert. You are observing the component is machined in the here in the core insert, and here, and this one is the parting line, and this one is the parting line, and this one is the parting line between this cavity insert and core insert. Here you are observing this one, you are observing this one, You are observing this one. You are seeing clear picture of the, this one is the sleeve, this one is the sleeve, this one is the sleeve, this one is sleeve, and you are observing this one is sleeve, and this is the core pin. This is the core pin. You are observing here the core pin. You are observing here this is the sleeve, and it is the core pin. Core pin provides the internal diameter or internal profile of the component, and on the sleeve you are seeing the profile of the component. You are seeing the profile of the component on the sleeve. At the same time, this position you are seeing in the core half. At the same time, you are also seeing in the cavity insert. In the cavity insert, you are getting the, in the cavity insert you are seeing the component profile, internal component profile, by providing the core pin, in the cavity insert. There are the core insert. Here there are two core inserts, one side in the core half, another insert in the cavity half. You are observing another insert in the cavity insert and another half in the core insert. At the same time, you are observing the another core insert which is placed in the core insert. You are seeing the core inserts. Here. You are seeing the core insert here. Now you are come to know that this is the component area. This is the component area. You are observing here. It is the component here with the help of the core pin. You will get the complete component by providing the submarine gate with the trapezoidal modified runner. Now you are observing the tool of the component. I had made the reference component for your purpose. You are seeing the top view of the tool and front view of the tool. Top view of the tool with 4 cavities, and at the same thing you are observing the front view of the tool. Here I am going to introduce the top view. Here you are observing the top view of the tool, and you are observing the 4 guide pillars and guide bush. 4 guide bush, 1, 2, 3, 4, and the ejector pin fasteners, 1, 2, 3, 4 for ejector guide pillar fasteners, and the ejector assembly. Here ejector assembly fasteners are here, 4, 1, 2, 3, 4, and the feed buttons which are used to rest the ejector assembly, 1, 2, and 1, 2, and here 4 feed buttons are there. With this you are observing the 2 ejector guide pillars and guide bushes, 1, 2 ejector guide pillars and guide bushes here, and you are observing the 4 pushback pins, 1, 2, 3, 4 pushback pins or retainer pins, and you are observing the 1, 2, 3, 4 screws. Here is there 4 screws, 1, 2, 3, 4 are here, 1, 2, 3, 4 are here, which are used to, where Allen screws are used to hold the core insert in the core housing plate. Now in the top view of the tool, you have seen the elements of the mold, and you are observing the insert here. One insert is there, that is made up of the HDS. This is the insert. You are observing this insert I had placed here. This insert is this insert, and I had given the dimensions of this one 230, and thickness is the 40 mm, and the length width is 230 into 230 mm. Here 4 1 2 3 4 cavities are machined. 4 cavities are machined in this insert, and the same insert are showing here. In this 4 cavity insert, they are used to fill the molten metal by the runner, by the main runner and the sub runner. Main runner diameter is 10 mm and the sub runner diameter is 8 mm. This runner is the modified trapezoidal runner, and at the same time you are observing the screw puller pin with the screw puller bush. You are observing the screw puller pin with the screw puller bush. Here, along this the top view of the tool, the same projections are drawn to draw the or to design the front view of the tool. And you are observing here the elements of the tools are bottom plate, core retainer, core pin retainer plate, spacer, core back plate, core housing plate. This housing plate I shown in here. You are observing this one. This core housing plate I am showing in here. In this core housing plate, core insert is fixed. This one is the core insert. This core insert is fixed in the core housing plate with the help of the Allen screws. With the help of the 4 Allen screws, 1, 2, 3 and 4. With the help of the 4 inserts, in this core insert, again local core inserts are fixed here. In this core insert, here the local core insert is fixed. This insert is placed. This insert is placed in this core insert. This core insert and this core insert both are same. I am showing in this one front view of the core insert. This core insert is fixed here. These core inserts are 4 numbers. 4 numbers for the 4 cavities. 1, 2, 3, 4. For the 4 cavities, 4 inserts are placed in the main insert. This insert going to place in the core housing plate. Here you are observing the core housing plate, and this core housing plate you are observing the core insert plate, and in that core insert plate you have placed the core insert. Core insert plate is 1 number and core inserts are 4 number because of the 4 cavities. And continuing this, you are observing the above the core insert, you are observing the cavity housing plate. In this cavity housing plate, again the same thing, cavity insert, and then in that insert again we have to going to insert the core insert, which is going to give the internal profile of the component. This one is the internal profile, and internal profile. And by coming to the sizes of the plates, you well known that the bottom plate is 27 mm and the core back plate or core retainer plate, that is core pin retainer plate, that is also 22 mm, and the length of the spacer is 50 mm, 45 to 50 mm, and the back plate is 22 mm, and the core housing plate, you are seeing here the core housing plate thickness is 56 mm. Above the core insert, cavity insert plate is there. The cavity insert plate is also 56 mm, and the top plate thickness is 22 mm. And now in continuing with this, by the molten material which is fed through the sprue, the molten metal which is fed through the sprue and it comes to the sprue pillar, and again it comes through the runner. That runner is the trapezoidal modified runner, and through the runner it enters into the cavity by the gate. You are observing here that gate is called as the submarine gate. That gate is called as a submarine gate. It is the one kind of the gate which is degated the component automatically or degated. Through the gate the component fills here. You are observing through the gate the component will fills here. Here you are observed that the component is completely filled by coming by the molten metal coming through the feed system. That one is the sprue, and then runner, and then the gate, and then the cavity. Similarly, simultaneously the material comes here, and through the runner the material enters through the gate, and the completely component will fills at the same time. Material comes here through the runner, it through the main runner it enters into the sub runner, and through the sub runner it enters into the gate, and through the gate the component, the molten material, fills through the cavity in the 4 cavities simultaneously, and by providing the curing time the component is solidified. After the solidification of the component, that is the cure time, with the help of the sleeve, I am shown here, with the help of the sleeve, after the completion of the curing time, when the mold opens, with the help of the sleeve, the ejector assembly moves forward. With the help of the sleeve, the component is bumped off. Or it is jump ejected, or the component is jump ejected. As you know that in the component you have seen the angle. Through this angle the component have some hindrance for the ejection. So by the force of the ejection through the sleeve, the ejection is called as a bump of ejection or jump ejection in this type. Again, simultaneously the 4 components are ejected from the cavity. Now you are seeing for the cooling system. Here we had introduced annular cooling system. Here you are observing that this is the inlet for the cooling water to come inside, and it revolves around the first, second, third, 4 cavity, comes here and revolves, again it moves, and it again revolves, and it moves here, again it revolves, again it moves here, again it revolves, and it will be come outside. This method of cooling is called as a annular cooling method. Respectively, along with the requirements, you have to make some of the drilling operations in the core insert, and the clearance operations are made in the core housing plate and the core insert plate. You are observing this one, and when you are going to draw in the parts of the tool, you are observing that the sleeve is placed here. This is the sleeve. This is observing the sleeve. This sleeve is placed here, and you are observing the core pin. Shown here. This is the core pin in the core side. Core pin. This is the core pin. You are observing. This is the core pin. You are observing in this. This is the core pin. This one is observing in the core side, and this is one the sleeve. This is the sleeve. And At the same time, you are seeing in the cavity side there is one insert. The same insert you are seeing here. This is the insert which is in the cavity side, and one another course insert is there, that is also in the I'm shown here. But when you going to draw the core pins, especially in the bump of ejections, you have to give a draft. You have to give the draft, permissible draft. You have to give the permissible 1 degree draft, which the dimension should be within the tolerance of the component. And with the reference to the top view of the tool, now you have to section the top view of the tool. Here what we have to cut, one thing is you have to cut for the this one, and I didn't show here the guide bush, and you have to show the ejector fasteners, and then you have to go for the component sectioning, and then you have to go for the screw puller and screw puller bush hatching, and then you have to come outside that. This sectioning is called the sectioning AA dash. Accordingly, you have to hatch the plates. According to you have to hatch the plates. You have to hatch the plates respectively. Here, respectively, you have to hatch the plates. Here. To hatch the plates. Hatch the plates. For your reference, I am giving the core. This one core insert. What I had made here. This HDS made core insert. That core insert dimensions is 230 into 230. Thickness is 40 mm. Respectively, core housing plate thickness is 56 mm. With the reference with the core insert, you have to draw the 1:1 core housing plate. This tool is a 4 cavity typical mold. You have to draw the top view of the tool, front view of the tool 1:1, and maintaining the shrinkages of the POM metal as per the shrinkage allowances, and you have to draw the 1:1 drawing, and you have to complete the designs. Now you are observing the total sheet in which you have to going to draw 1:1 drawing. And for any doubts, you have to contact me on the in the online classes. Thanking you.